All right, hello students. Today we're moving on with lesson 24, true and false number sentences. So we're going to talk about different types of number sentences, different types of inequalities, greater than, less than symbols, and equal to signs. And we're going to state whether they're true or not and kind of talk about other different forms of this. So let's go ahead and look at opening exercise. To state whether each number sentence is true or false, and if the number sentence is false, explain why. So we look at the first one. It says 4 plus 5 is greater than 9. Well, hopefully you recognize that 4 plus 5, whether you do it kind of on paper or in your head, 4 plus 5 is 9. And you kind of rewrite the statement, because the inequality stays the same, it's still greater than, the 9 stays the same. So here's our statement. 9 is greater than 9. Is that a true statement? And the answer is no, it's not true, it's false. And so because it's false, we have to explain. It's false because 4 plus 5 is not greater than 9. It's equal to it, but it's not greater than 9. So this would be a false number sentence because this inequality is here. If this was an equal to symbol, then it would be true, but since it's not, it is just simply false. As we move on kind of to the next one, the same thing. Over on one side, we have an operation. We have some multiplication going on here. So you want to do that operation. 3 times 6 is 18. And then you go ahead and bring down everything else. We kind of look at the statement here. Is 18 greater than equal to 18? And the answer is yes, it is. So since the answer is yes, that would be just simply a true statement. So since it's true, we don't have to give an explanation. It just simply is true. As we go and continue moving on, now it's kind of almost written backwards, some people like to say, because the operation now is on the right side. That doesn't change anything. We just simply have to go through it the same way. Nothing's changing on the left side, so 32 is greater than, and now we do the division. Well, remember when we divide, the fraction bar, means division. So when we divide, the bottom number goes into the top number. Now you can do the work on the side over here, nothing wrong with that. So if we look at this, 4 goes into 6 one time, that would give me 4. Subtract, that would get me 2. And then on the 4, and then 4 goes into 24 6 times. So this fraction over here really means 16. Notice the denominator goes away because 4 goes into 64 evenly. Sorry, I forgot this last part. Because there's a 0 here. It means there's no remainders, there's nothing left over. The question is this a true statement? Is 32 greater than 16? And the answer is yes, it's true. So that's it. Done. We go and continue working our way through this. We take care of D, we do the subtraction. Well, 78 minus 15, 8 minus 5 is 3. 7 minus 1 is 6. So is 63 less than 68? And the answer is yes, it is. Therefore, it is a true statement. Some people won't write the other side. They'll kind of just do the operation and then compare these. That's perfectly fine too, as long as you kind of can see that. And I'll kind of do that on this one right here. And the last one here, once again, the operation on the right-hand side, so we just go ahead and take care of it. Over here, 11 plus 12 is 23. So now we have to look at the full statement. Is 22 greater than or equal to 23? And the answer is no. So that would be a false statement. Now explain why. Well, this is false because 22 is not greater than 23. This is false because 22 is not greater than or equal to, because remember the line underneath this right here means greater than or equal to, sorry I forgot that part, or equal to 23, which is the answer to 11 plus 12. All right, so that's kind of what we're talking about today. We're going to kind of deal with these equations and inequalities, talking about whether they're true or these statements are true or false. So we look down the next, you see this kind of table here. It simply says, right, true or false, if the number substituted for G results in a true or false statement. So here, look at the kind of left side here. Here are all different types of values for G. So if we let g equal 8, would this one be true? Would this one be true? And so forth. We could kind of fill out this row. If g is equal to 4, would this be true? Would this be true? And so forth. So we want to kind of fill out this row. So let's go ahead and kind of go through, let's go ahead and talk about kind of this first kind of column here, and then we're going to talk about kind of the top row, and I'm going to give you a couple kind of to fill in, okay? If we kind of go through this first column right here, and this says 4 times g, remember it needs to be multiplication, is equal to 32. So now we got to say, well, if g is equal to 8, would this be true? Well, 4 times g, in this case is 8. 4 times 8 is 32. So is 32 equal to 32? And the answer is yes, that's true. I'm just going to go and put a T, kind of save us some time. If I keep going, 4 times 4, right, because now g is 4. 4 times 4 is 16. Is 16 equal to 32? And the answer is no, so it's false. As you see, we can keep going through this. 2 times 4 is 8. Does that equal 32? No. 0 times 4 is 0. Does that equal 32? No. 10 times 4 is 40. Does that equal 32? And the answer is no. So all of those are false except 8. That's the only thing that equals 32. Now we're going to kind of go the other way. We're going to kind of go through the row here, and we're going to substitute 8 in for all the different g's to see if they make sense. So if we look at this one, g is equal to 8. Well, if g is equal to 8, does 8 equal 8? Yes, so that's a true statement. For the next one, remember g times 3 or 3 times g is greater than or equal to 32. So if I plug in 8 for 3, 8 times 3 is 24. Is 24 greater than or equal to 30? And the answer is no, so that would be a false statement. If I keep going, if I plug in 8 for g, is 8 greater than or equal to 10? Nope, that's a false statement. Next, 8 divided by 2, because g divided by 2, I'm letting g equal 8. Is 8 divided by 2 greater than 2? Well, 8 divided by 2 is 4. Is 4 greater than 2? Yes, so that's a true statement, so I'm going to put T. And kind of moving on, is 8 greater than 4? Because g is greater than 4, the answer is yes, so that's a true statement. Got a couple more. Is 8, if I plug in 8 for g, so g greater than or equal to 8? Well, in this case, g is 8. So therefore, 8 is greater or equal to 8. So the answer is yes, that's true. So now what I would like you to do is go through the row for at least for 4 and for 10. So on this one, you're going to let g equal 4. And on this one, you're going to let g equal 10. If you want to do the other ones, that's perfectly fine. But I want you to do at least these 2 rows. I want you to fill out the entire rows here. And I want you to come back, or actually go to the next video and check your answers to see if those rows are correct or not. All right, so that's the end of the first video. Go ahead and stop it. Go ahead and move on to the next video. We'll talk about the answers, and then we'll move on to some other exercises. All right, hello students. Now we're going to move on to example 2. It's to state when the following equation will be true and when will it be false. So we're going to have to answer kind of 2 different questions. When will they be true and when will they be false? Well, because we have to kind of state whether true or false, we have this thing called a variable sitting here. So we have to think about what could this variable be equal for this statement to be true, or what could this variable, in this kind of case, be greater than or less than to be equal to make this statement true. So if we look at this, we got to think about what could r be to make this statement true. And this is kind of like a guess and check. If r was 5, would this be true? Well, 5 plus 15 is 20. Is that equal to 25? The answer is no. But if r is 10, 10 plus 15 is 25, well, then that statement is true. So r has to equal 10. Now the question is, can r equal anything else? The answer is no. So r cannot equal anything else. So how we write that is we put r, we put an equal to sign, we put a line through it. This means r cannot equal if R does not equal 10, this statement is false. So if R is anything else, we don't want to write every number out there. We want to, this is a symbol we use for any 10. Statement now would be false. So that's kind of what we're doing for each of these. We want to kind of think about what would make them true and what would make them false. So same thing for our next one, but now we have an inequality. We have 6 minus d is greater than 0. So, and what would make it 1 in here? That'd be 6 minus 1 is 5. 5 is greater than 0, so yeah, that would be true. But is that the only thing? No, I could put 5 in here. 6 minus 5 is 1. 1 is greater than 0. But what we'll look at is, what if I put 6? 6 minus 6 is 0. Is 0 greater than 0? No. So D, excuse me, has to be anything less than 6. It can't be equal to 6, but it can be anything less than 6. It can be 5, it can be 4, it can be 3, it can be 2, and it could be 0. The opposite is kind of up here. Well, if D is anything greater than or equal to 6, well, then the statement would not be true. As you see, I kind of use the opposite inequality, but also I use the equal sign, because if it's 6, it's still not true. All right, so let's go ahead and go down to C, kind of the same thing. What would make this true? What would make this false? And so we got to think about it. Remember, this means multiplication. 1/2 times F equals 15. Well, if you think about it, what number times half gives me 15? And hopefully you think, you kind of hopefully come to the realization that if F equals 30, right, because half of 30 is 15, if F is equal to 30, well, then that's true. Well, very similar to A, that means if F is anything other than 30, so if F is anything but 30, well, then that statement would be false. And that's kind of it. That's kind of all we're looking into. If we do it for one more time, for one more inequality, we have a true statement, and we have a false statement. Just go ahead and go down just a little bit more. What would make this true? Well, this is y divided by 3 is less than 10. Well, if we kind of treat this like an equal sign, kind of like we did like this one, what divided by 3 equals 10? Well, that's 30. Well, if you do that, you can simply say that y has to be anything less than that answer, anything less than 30. So if you treat these inequalities like you treat the equation, you kind of think about, well, what was half of what gives me 15? That was 30. Y divided by what gives me 10? That's 30. Well, then you have your answer, y less than 30. And now the opposite will be true or be the false part. Y is greater than 30. That would give me a false statement. So if I say y is 60, 60 divided by 3 is 20. 20 is not less than 10. Like I said, because y is greater than 30. So therefore, this would be a false statement. All right, so now what you're going to do is you're going to pause the video, you're going to try this on your own, and then come back and you can check your answers. So go ahead and stop the video real quick. Go ahead and come on back, and I'll go ahead and give you the answers. All right, so this is complete the following pairs. This is state whether equation inequality will be true or false. So very similar to what we just did. So let's go ahead and I'm just going to go ahead and write T for true and F for false. So hopefully you give this a try. For a true statement, you should hopefully have C is greater than 15. Again, oh, sorry, not 15. I'm sorry, I was confused. It should be 3. I apologize. I was thinking about the 15. I was thinking about the 15 next to C. I apologize there. So it should be 3. And for the false would be the opposite. C is less than, sorry, or equal to 3. So as you can see, if we talked about this, 15 times 3 is equal to 45. So therefore, C has to be anything greater than 3. Same thing for the next one. The true, we would have D would have to be equal to, what was that, 35? And for the false, we would need the opposite. The false would be the opposite. Instead of D being equal to, D would not be equal to 35. It would be anything else. And for the last one, once again, if we kind of make this inequality an equal sign, 2 times what gives me 56? Well, that's 28. So E, now this gets a little tricky here because this is on the right side. So if we notice, the kind of pointy end or the less than side is pointing towards the E. It has to be pointing towards the E here, but we always want to write the variable first. So if you did it backwards, it's okay, just kind of rewrite it over here. E is less than or equal to 28. And so the false would be the opposite. E would be greater than and not equal to 28. So if you kind of look at this one, you look at 1 and look at 3. C is greater than 3. The opposite of that is less than or equal to 3. Look at this one, equal to 28. The opposite of that is greater than, no equal to sign. So if there's an equal to sign on one, there's not an equal to sign on the other when you're talking about true and false. All right, go ahead and pause the video. Got one last thing to kind of cover in the last video. I'm ready to take care of these. All right, hello students. Moving on here, we're going to kind of talk about when a proper inequality or equation would be used. So it says identify all equality and inequality signs that can be placed in the blank to make the statement true. So we look at this kind of one that says 15 plus 9 equals 24. Well, like before, we want to take care of the operation. I always like to take care of the operation and say, okay, this is what this really means. This means 24 blank 24. Well, what signs could go in here? Well, hopefully you kind of recognize right off the bat that these are equal to each other. That's one possible sign. There are actually a couple others. Remember, because these are equal to each other, we could use the greater than or equal to symbol. We also could use a less than or equal to symbol. All of these three would actually fit properly in here. That's because this is equal to each other. So either the equal to sign, greater than or equal to, or less than or equal to. We move on to 9, kind of the same thing. First, we want to take care of the operation. What does 8 times 7 mean? Well, that means 56. So now we have to look at, well, what signs can we use? Remember, we have the equal sign, less than, greater than, less than or equal to, greater than or equal to. Well, here, the only two signs we could use are the greater than or the greater than or equal to, because 56 is work. We have to simply just need to have that greater than symbol. All right, so what I want you to do, I want you to pause the video. I want you to try these 3 on your own, come back, and we'll talk about what the answer should be. All right, so hopefully for number 10, you gave it a try. Hopefully you did the division. Well, half of 15, hopefully you recognize is 7.5. Well, of course, this left side is less than 10. So it's very similar to this. So the left side is less than, we also could put less than or equal to. We went down to the next one. Hopefully you did the multiplication here and got 34. So now we have 34 is equal to 34, or 34 is less than or equal to 34, or 34 is greater than or equal to 34. Now, of course, the order you have these doesn't matter. You just need to have all 3. And the last one down here, hopefully you did the subtraction here. Remember, line up decimals. The decimal point for the 6 is right here when you do the subtraction. And 24.5 minus 6, hopefully you got 18.5. So it's not equal to each other. This left side is less than the right side, so hopefully you have less than the less than or equal to symbol. All right, so those are kind of one more thing we're talking about when we talk about writing inequalities, true or false statements. All right, so go ahead and stop the video now. Now you should be prepared on to the assignment for today.